In this video we will design the profile of a cam. Then the problem is a cam with minimum radius of 25 mm is to be designed for a knife edge follower with the following data. Number 1, to raise the follower through 35 mm during 60-degree rotation of the cam. So angle of ascent is 60 degrees and the maximum height of the follower h is equal to 35 mm. Dwell for the next 40 degrees of the cam, 40 degrees rotation of the cam. So for the next, after ascent, the follower is at the highest position. Then for 40 degrees rotation of the cam, the follower must stay at the highest position. So it should remain stationary for 40 degrees rotation of the cam after ascent. Third point is descending of the follower during the next 90 degrees of the cam rotation. So after 40 degrees dwell, then for the next 90 degrees rotation of the cam, the follower must descend. And then dwell for the rest of the period. For the remaining out of the 360 degrees, the follower must be at rest or dwell. Draw the profile of the cam if the ascending and descending of the cam is with simple harmonic motion. So the ascending of the follower and descending of the follower is both by simple harmonic motion. The rise and fall of the follower is by simple harmonic motion, and the follower is of the knife edge type. And there is another different thing which you have to know here is the line of stroke of the follower is offset 10 mm from the axis of the camshaft. So this is a offset cam system, offset of 10 mm. So that we will see how to handle it when we draw the profile of the cam. So first we have to draw the displacement diagram, and of course he has given the speed of the cam, and we have to find the maximum velocity and accelerations during ascent and descent, and speed of the cam is 150 rpm. So these are the given values here. H is equal to 35 mm, phi a is equal to angle of ascent, phi a is equal to 60. This dwell 1 is delta 1, that is equal to 40 degrees. Then angle of descent, phi d, equal to 90 degrees. The speed n of the cam is 150 rpm, and the minimum radius or base circle radius RC is 25 mm, and offset of the follower is 10 mm. It is denoted by small letter x, and it is 10 mm. So again we will take a scale of 1 centimeter equal to 5 mm. So the maximum height of the follower h is equal to 35 mm. So in centimeters it will be 7 centimeters. So according to this scale. So now we will draw the follower displacement diagram. We will draw a vertical line of height 7 centimeters. Then we draw a horizontal line of an arbitrary length. Next, you see that we have an ascent of 60 degrees. So whatever it is, 60 or 90, we will just take 6 parts, 6 divisions. We will make 6 divisions here. We will draw the upper line also. Now we will divide it into 6 parts. First part, second part, third, fourth, fifth, and sixth part. Then we will leave a little bit of gap for the dwell. After that gap for the dwell, again we will divide it, the displacement diagram, into again 6 equal parts for descent of the follower. So once again you remember that there is no need to take any scale for the x-axis. So just divide it into 6 equal parts. Now draw a semicircle here on this, on any side. You can draw it on this side or on this side. So now we will divide this semicircle into 6 equal parts. So now we have divided it into 6 equal parts. Now mark the numbers starting from here. So 0, 1, 2, 3, 4, 5, 6. So we will use the same semicircle for drawing the ascent as well as the descent of the follower, because both are of simple harmonic motion. So the ascent will start from 0, 1, 2, 3, 4, 5, 6. Then descent must come in reverse direction. So after 6 we have 7, 8, 9, 10, 11. So we will use the same semicircle to draw both the ascent and descent. Now we will number the displacement diagram on the x-axis also. 0, 1, 2, 3, 4, 5, 6. So this will be again 6, 7, 8, 9, 10, 11 and 12. Now from 1 and 11, so this point is 1 and 11 also. So what you do is, from this point draw one line up to 11, and same thing you continue up to 1. Okay, then you draw from 2, continue it up to 2, then of course from 3 continue up to 3, the third line here on the left. Then from 4 draw up to 4, then 5 draw it up to 5. So our points are now for ascent. This is the first point, second, third, fourth, and this point. And finally on this diagram here, this will be the point 7, and then 8 and 8, 9 and 9, 10 will cut the line 10, 11 will cut the line 11, and 12. Okay, so you see that. See here we have now 1 and 11 on the semicircle. So this line must intersect the vertical line 11 and also 1. So this point and this point we have here. Of course 0, this point and this point will be 0 and 0. Then here we have 2 and 10. So 10, so this line intersect 10 here, vertical line 10 here, and the vertical line 2 here. So you get these 2 points. This is 3 and 9. So it intersects 9 here and 3 here. This is 4, 8. So it intersects 8th line here and 4th line here. And here we have 5, 7. So it intersects here, the 7th line, and the 5th vertical line here. So now we join these points using a smooth curve. So this will be the ascent of the follower, displacement diagram for ascent of the follower. And the other side we have the descent. So both are by simple harmonic motion. So join all these points using a smooth curve. So this is our displacement diagram for the given problem. Okay, and of course we mark this point, these points here, wherever it has got. This is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. So this will be again 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash. So these distances 1 1 dash, 2 2 dash, 3 3 dash, all these distances like 7 7 dash, 8 dash, 9 9 dash. So these distances are the rise of the follower at the given instant of time. So this is you see, this is the angle of ascent phi a, and this is for the descent phi d, and this is delta 1. So 60 this is 60 degrees, delta 1 is 40 degrees, phi d is 90 degrees. So delta 2 will be 360 minus 60 minus 40 minus 90. So 300. So it will become to, so delta 2 is equal to 170 degrees. So that is the dwell at the lower position. Okay. So knowing all these, having all these lengths of the follower, ascent of the follower. Say here this is, so this is 60 degrees. So 1 centimeter will represent 10 degrees of rotation. So after 10 degrees of rotation, the follower must rise by this amount, 1 dash. After 20 degrees of revolution of the rotation of the cam, the follower must rise by a height equal to 2 dash. Similarly, after 30 degrees, it should rise by an amount equal to 3 dash, so on. So when it turns for full 60 degrees, the ascent of the follower must be 6 dash. Similarly, this is descent. Okay. Again, we have divided this 90 into 6 equal parts. So this each division will be 15 degrees now. So 15 degrees, each division will be of 15 degrees. So after 15 degrees of rotation, this will be the height, 7 dash. After 30 degrees of rotation of the cam, the height is again decreasing. The height will now be, height of the follower will be 8 dash. And again, after 45 degrees of rotation, the height of the follower will be 9 dash. Then 10 dash after another 15 degrees. After another 15 degrees, it is 11 dash. And after another 15 degrees, that is total, after 90 degrees rotation of the cam, the follower has totally descended from the highest point to the lowest point, or a descent of 35 mm. Okay. So this is the displacement diagram we have to draw for this problem. So in the next video, we will see how to draw the profile. Of course, this is a offset follower.